Mars is rusted. Not metaphorically red, not painted red by dust, actually rusted, coated in the exact same iron oxide that eats through a bike chain left out in the rain. Scoop up a handful of Martian soil and you are holding rust, roughly 18% iron by weight in some spots NASA's rovers have tested. Here's the impossible part. Rust needs water and oxygen working together, and Mars has had neither in any real amount for about 3 billion years. So how does an entire planet rust bone dry? The answer starts underground, in places like Gale Crater and Jezero Crater, where NASA's Curiosity and Perseverance rovers have been drilling since 2012 and 2021. Both rovers found something that shouldn't be there on a supposedly dead world. Layered clay minerals and streambed pebbles, smoothed the way only tumbling water can smooth a rock. Mars wasn't always the dry rust bowl we see today. Somewhere around 3.5 to 4 billion years ago, it had rivers, lakes, and by some estimates an ocean covering nearly a third of its northern hemisphere, deep enough to drown Texas. That ocean is the missing ingredient. When Mars still had liquid water, it also had a magnetic field, generated by a molten iron core just like Earth's. Then, around 4 billion years ago, that core cooled and the magnetic field collapsed. Without it, the solar wind ripped away most of Mars's atmosphere, and sunlight tore apart what water was left, splitting it into hydrogen, which drifted off into space, and oxygen, which had nowhere else to go but into the ground. That freed oxygen bonded with iron already sitting in Martian rock and dust, and the whole planet slowly rusted from the inside, one molecule at a time, over hundreds of millions of years. If you want the next planet's secret the moment it drops, subscribe now, because we post a new one of these every single day. What makes this stranger than a simple color change is that Mars is, in a sense, still rusting today. Global dust storms, the kind that swallowed the entire planet in 2018 and grounded the Opportunity rover for good, keep grinding rock into fresh iron-rich powder and exposing it to trace atmospheric oxygen and ice. Perseverance is right now caching sample tubes in Jezero Crater. Samples a joint NASA and ESA mission is scheduled to physically return to Earth around 2033, specifically so scientists can read the rust like a timestamp and pin down exactly when Mars's water disappeared for good. Drop a comment if you think that sample return mission finds something nobody's expecting. So the red planet isn't red because of paint, dust color, or a trick of the light. It's red because it is, quite literally, one giant rusted-out shell of a world that used to be wet enough to hold an ocean. Every sunset photo a rover sends back is a picture of oxidation frozen in time, a scar left by an atmosphere that vanished eons ago. Hit the bell so you don't miss what the Mars sample return mission uncovers when it finally lands.